Okay, we're talking about loans and investments. Why would you ever take a loan? A lot of people, like me, feel like loans in general are a bad idea because you have to pay interest on them. So like there's a lot of people who get trapped into buying things on a credit card and then stretching it out over time, and credit cards can charge ridiculously high interest rates, like 30% interest. And it can turn a $1,000 purchase of a stereo you just kind of wanted into costing you double that, literally, like $2,000 after you pay for all the interest you have to pay on a credit card. So I don't like loans, but I took a loan out to get my house. Almost everybody has to take a loan out to get a house. Because you don't just start out with enough money to buy a house outright. So you pretty much are going to have a loan for your house. And then most people nowadays are coming out with loans for college. Many of you are going to make it where you won't have to have loans. I'm really hoping I can get my kids through college without loans or with loans that are very small. But the average, just so you know, perspective-wise, the average kid nowadays is coming out with around $28,000 in loans after college. So that's a really common thing. Mom and dad can write the check for the whole thing. That's awesome. Or if you were able to pull it off yourself, that's much harder to pull off paying for college yourself. Typical tuition, room, and board at even a cheap college in Minnesota, the cheapest one I know of is $15,000 a year for tuition, room, and board. The cheapest way to go is about $9,000, and that's to go to Normandale and live at home. So I'm sure somebody's even got a cheaper way to do it, but it's going to be like $8,000-9,000 on the low end. On the high end, go to like St. Olaf and pay the tuition full. I went there, so I'm not trying to pick on Olaf. I like Olaf; it's a great school, but its tuition, room, board is like $53,000. So it's really tough for a kid to come out of college without debt if you go to a really high-priced place, and even a low-priced place. Not many of you over the summer can make enough to pay like $9-10 grand to go to college. Now, if you got a full-time job, and then you could probably do it, but man, how are you going to go to college and have a full-time job? That's tough to do. So a lot of people end up getting loans. I'm just trying to set you up for why do we talk about loans and investments. Well, there's two kinds of loans you might have. You might end up with a college loan. You might end up with a house loan, and I hope you don't have loans for too much more than that, because every time you're paying a loan, you're making money for the bank. Money that they like to make on you as you're buying that car. They'd really like it if you will pay them interest, because then they get, if you buy a car typically for $20,000, by the time you're done paying off the car loan, you've paid $25,000 because they made $5,000 in interest on you. That's why banks can put up great big buildings. And it's okay for them to make a profit, but you want to try to avoid loans as much as you can to be a smart consumer. Most people would say loans for a house or loans for college, as long as they're small, is probably a good investment. All right, now take a look at this townhouse. You see the price at $119,500? All right, if you go to the base information on this house, that house was $193,000 back in November of 2004. So I want to remind you, back in November of 2004, that's 10 years ago, the house was worth $193,000, and now it's worth $119,000. So do houses always go up in value? No. This was right at the bottom of the market here in Maple Grove, this particular townhome, and it may have sold since then and actually gone up in value. But all I'm trying to say is houses don't always go up in value. All right, go to the next slide here on the green one, growth, decay, and the common ratio. All right, you notice how in the notes they say to do the same thing I told you yesterday? It's really smart to do 1 plus the percent change or 1 minus the percent change if it's decay. All right, so I'm going to give you a number. Let's say that you have 10 going down to 6. If you take this divided by this, do you agree you'd get 6/10 or 0.6? Would you tell me then on your iPad what's the percent change? Write it down, turn it my way. Only got 2 people turned it my way. Come on, you can go a little faster than that. What's the percent change? All right, I am getting different answers, but most of you are zooming in on the right one. When you divided 6 divided by 10, is that the percent change? That one comes out to 0.6. What you do is you do 1 minus that 0.6 to get the percent change. And that would be a percent change of 0.4, as in 40% change. Okay? That is confusing. It seems like it's 60% change because you got this 0.6 number, but it's not. You do 1 minus that to get your percent change. 40%. Most of you had that right. Okay. Now, if I go back to a sequence that goes up, let's say I have 10, and then it goes up to 12. If I divide that one, 12 divided by 10, can you do that in your head? 1.2. Very good. So if 1.2 is my answer, then what is the percent change? Is it 1.2? Is it 0.2? Is it 0.8? Write down what you think it is and turn it my way. What's the percent change? All right, many of you, but I'm still waiting for a lot of you. Okay. All right. I'm seeing almost everybody getting it right, and it is the 20% part, as in 20% change. And I think, I'm not even going to have you turn this one my way, but do you know, is it growth or decay? That's growth. If you go from here to here, that's growth. It's getting bigger, so that's growth. All right. So let's go back to this now. Go to the examples page. In 2006, small town has a population of 1,500. However, it's predicted the population is increasing by 3% each year. By now, you should be able to write a little formula for that really easy. But there's 3 choices for U sub whatever. It's going to start at 1,500. The question is, what do you put there? And there's 3 different things. Would you write down what you think we should put for that? U sub what? And then turn it my way, zoom in on it so I can see if I agree with you. All right, I'm starting to see some answers come in. I'll be able to tell you right or wrong in a second. Can you turn your brightness up so I can see? All right, I'm agreeing with almost everybody. Some of you on the right side aren't showing me, and I appreciate it if you give it a shot. Okay, all right, I'm seeing different answers. Would you agree that the 3 choices were U sub 1, U sub 0, or U sub 2006? I think this is the best one. I like that the best because then when they ask you what will the population be in 2020, you can just do U sub 2020. Okay? So get used to when to use the right or when to use the year. If you had done U sub 1, that'd be good if they were going to say, what is the 10th term? Because then U sub 10 is the 10th term. But if it's a real world problem and they hadn't given you a year, then you should use U sub 0. So if it hadn't said in 2006, if it just said a small town has a population, blah, 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 you'd use U sub 0. You get that? All right. So now would you actually put that into your calculator? I would do U sub 2006. And then U sub n minus 1 times something, I hope you know what, from the problem. And then last thought, a lot of people in the middle of the test, one of my colleagues brought this up to me, and he's right. He said a lot of kids forget how to put in the U sub part in their calculator. And if I see a kid who's getting an answer that's all screwed up, 9 times out of 10, it's that middle line on the calculator. So I want everybody, just for practice, because what if you by accident delete this whole thing like this? You clear it out. There is nothing on the middle line. This top one was 2006. I want you all to clear your middle line right now. I want it to be gone, empty. The third line was how much we started with, was 1,500. I want you to just show kids sitting next to you that you've got those 2 numbers incorrectly and nothing on the middle line. Turn and show them right now. Have you shown anybody? Okay. Now, I want you to recreate that middle line right now so that there's no chance that you have forgotten where those numbers come from. Because if you're stuck on that, I'm not going to tell you. I'll tell you today, but I can't tell you on the test. This middle line here, it says u sub n, so you have to type in u sub n minus 1 in parentheses, and then the rest of it. Now, the thing that people goof up here, sometimes they use capital U. That won't work. The calculator thinks of capital U as something completely different than lowercase u. Another common thing is people just forget the u, and they type n minus 1. You have to have the u there. All right. So here's how it should look. It's right above the 7. That's the u. Sub. And the n is right on the x key. N minus 1 and parentheses. And then I need times. And then I should always, for these loans and investment problems, put a parenthesis right here. It is actually true you wouldn't have to, but it could screw things up if you typed it a certain way. Having a parentheses there is a safe way to do it. 1 plus, was this growth or decay? It was growth, I believe. I'm going to double check. Yep, increasing by 3%. So I'm going to go with 1 plus 0.03. End parentheses. Enter. Now, let's go see what, when I quit on this thing, and clear this off, what U sub 2020 is, because that's the population in 2020. U sub, U, where's the U again? There we go, sub 2020. All right, did you get 2268? Raise your hand if you did. Okay. Good. It's not working for you. Ask the kid next to you. All you have to do is compare your y equals screen to their y equals screen. That's probably, if there's any mistake, it's something in there. You having trouble? All right. Then, of course, when will it reach 5,000? That's different. That's not U sub 5,000. I would recommend that you do one of two things on that. You could either graph it and then see visually when did it get up to 5,000, or you could use the table and see when did it get to 5,000. All right, I'd like everybody to try the table way right now, but first go to table settings. It's right above window, because if you're like mine and your table settings are at a weird place, it takes forever for the thing to stop processing. So let's get it to the right place in the first place. We want 2020, right? Got to clear that back a little bit. 2020. Counting by ones. And then I can go to my table. And now in 2020 it was 2269. Oh, that wasn't very good. I should have gone further, but that's all right. I can arrow from here. You just don't want to have to start arrowing from the year 2006 or something, you know, and have to arrow forever. I want to figure out where its population is. What is it again? 5,000. Okay, it's going up. It's getting closer to 5,000.
2047.
All right, you are correct. In the year 2047, it will finally hit 5039.8. Any questions about that? All right. So, could I have done that with a graph? Yes, and I want to show you how. Everybody, just hit graph. And if yours does what mine did, window range, then we have to go fix our window to make it work. So, go over to window. Oh, first I got to quit out of the error thing. I go over to window, and I got to think about it now. If my n min is 2006, that makes sense. The lowest n I'm going to use is 2006. My n max was 20. That wasn't making any sense. So I think we figured out that it was in like the year 2040 or something. So let's go to 2050. And that, if you didn't know what it was, just make it a fairly big number. Gives you lots of data points to use. All right, always count by ones. X is time. 0 to 20 would be 20 years. I want more than that. I want like 50 years or something. Just make it bigger rather than too small. If it's too small, you can't see it. If it's too big, the graph might be a little bit small, but it's okay. Y min is like the height, like the highest it will be. Right now, the highest my graph will go to is 2,000. I want it to go to more than that because my population is going to get all the way up to like 5,000, right? So I want it to go to like maybe 7,000 or something. All right, this is good for you to think through. I hit graph and see what happens. If it doesn't work, I'll adjust. All right, so something's wrong. Let's try to figure out what. We know we have data because we've looked at the table before. And our numbers are like in the year 2042, we have about 4,500 or so. So we should be able to see it overlap there. If I have X going out to 2047. Ooh, that's the no, wait. The N is 2047. I wonder if my X's need to be that high too. So I'm going to go to the window. N min and N max, those are big enough to work. Maybe my X min and X max aren't near big enough. Let's make those go all the way to 2050 also. This is what you'd have to do to just, you try stuff, see if it works. Ooh, it's way at the end there. Okay, now did I really need all this part of the graph? Do I really need to see all of that? No, that's a bunch of empty wasted space. So now I know it was my X number that was messing me up. So now I'm going to go to the window again. There's a lot of this in the real life. You play around with it till you find it. And so let's make this go from the year 2006 also to 2050. And now let's see if it looks nice. Ooh, there, that's a nice one. Okay. Then you did something different on your Y equals screen or your window screen. So look at your window. Does yours go from 2006 to 2050? Yeah. Okay, now we'll go down to your X's. Does it go from 2006 to 2050 on your X's? Okay, get that fixed and then it'll look better. Okay? Now, last thought. Yes, that's okay. I think you know which one was faster. In this case, which would you prefer? Table. Table's better. But it's just good for you to know how the graph works. And you might have a graphing question on the test and the calculators are allowed, so it's good for you to be able to use it if you need it. Okay. But I'm all in favor of use your technology, like don't make it like extra work to use your technology. Use whichever is going to work faster for you, and in this case, table would have been better. All right, let's move on. To this slide. A car loses 1/8 of its value each year. It'd be nicer if they told me a percent, but can't you change 1/8 into a percent really easy? Grab a graphing calculator if you haven't already. And if you need to borrow one from me, borrow one from me. I got a bunch up here. I had already 2 people borrow some, so. And I want you to take 1 divided by 8, and what decimal is that? 0.125. So then, if it's losing 1/8 of its value, here's the formula. U sub, does it tell me a year? No. So if it's a real world problem, U sub what? U sub 0. Unless they were going to say, find the 10th term. This is not the same as finding the 10th term. That's different. U sub 0 is going to work better for this problem. All right, so U sub 0 equals the starting amount, and that's right here. That is when it is new. So 23999. Then U sub n equals U sub n minus 1. And then I say always 1 plus or minus, and if this is growing or shrinking, what's it doing? Loses. What does that make you think? Shrinking. It's losing value. Don't think that when you buy a car it's going to go up in value. The only way that works is if you buy a collector car. And that is kind of a cool idea. Buy a car that's going to go up in value. But the problem with buying a collector car and driving it around all the time is then if you drive it around all the time, it won't actually gain much value because you're beating it down. You know, people want collector cars that are like pristine, like almost like they've never been driven, low miles. So anyway, it's really hard to find a car. And if you could figure out a way, that would be a genius thing. Because everybody out there is driving cars and their cars are going down in value. Almost everybody. 99.9% of people. You could figure out a way to drive cars and make them go up in value. That would be awesome. So figure it out. All right. 1 minus 0.125. And now remember, for your recursive formula, did anybody have the foresight to write n greater than or equal to 1 on their paper? Okay, you all would have lost a half a point then if this had been the test. Don't forget that part. That's called a domain. I have to check for it. Now, what it means is this formula only works on the second term because you need a term in front of it to make it work. So you just make it 1 bigger than whatever that is. So if it's a 0, then you say n is greater than or equal to 1. So this formula only works when n is bigger than or equal to 1, because u sub 0 has to be given to you. So the formula here can figure it out once you get to the second term, or sorry, in this case, the first term, because u sub 0 is the other one, the beginning. Okay, anyway, just make this and this a difference of 1. All right, next page. Let's talk about an investment. It's not always about loans and things that go down in value. Sometimes you actually put money in the bank and it goes up in value. So $2,000 into a bank account pays 7% compounded annually. This means the bank pays her 7% of her account balance at the end of every year. She leaves that in the account. So basically, her money's going to grow and grow and grow and grow at 7%. It would be, you're right. And in real life, no banks pay you 7%. But you can get something called bonds that'll pay you 7%. For instance, let's say a nursing home, somebody wants to build a nursing home, and they don't have enough money to do it. They can issue bonds and say, okay, if you will give me $100,000, you need a bunch of people like that. If you'll give me $100,000, I know I'm going to make enough money on my nursing home that I can pay you 7% interest. So then you give them the 100 grand, and they give you back 7% interest until the bond, what is called, matures. That gives them like 20 years to get their nursing home up and running, and you get 7% on your money the whole time. But you can't ever just like one day say, I want my money back. That's the deal on a bond, is you promise them they could have it for 20 years or whatever period of time. Then at the end of the 20 years, nursing home's up and running and everything, they can either take out a different loan and pay you back, or hopefully they have enough money made by then that they can just simply pay you back. They give you your $100,000 back, plus you've made the interest on it the whole time. That happens every day in the real world. Companies issue bonds. And the bigger and stronger the company is, therefore the more safe your investment is, the less they pay you in interest. So there are some companies that are brand new and people can't trust that they're for sure going to get their money back. Then they have to pay a really high rate of interest. Those are called junk bonds. But if you really believe in this person, they might be paying you, let's say, 12% interest, and you still, because you know them, you trust that they're probably going to give you the money back at the end. They're kind of a genius person, and they're likely to make this work. Well, then maybe it's worth the risk because you're going to get 12% interest instead of only 7% interest. That's a judgment call everybody has to make. All right, so this is good real-world math. And you can set up a little formula for it. Would you please do that? Put it in your calculator. It's fine with me if you don't even write the equation. Just put it right into the calc. Notice this did not give us a year. And since it's a real-world problem, you should use u sub 0. I'll pause for a second while you try putting that in the calc. Okay, so we got it in our calculator here. How are we going to tell when this thing doubles in value? You go over to the table. Now my table is set to go out to the year 2000 something. That's why it's running, and it's still going to be running for a long time. If this ever happens to you and you're like, oh, make it stop. Do you know there's a way to make it stop? Second. It's the off button, basically. Okay, because right above on is off, right? Okay, so if I just hit the on button, that didn't stop it, did it? Oh, there, it did stop it. Good. Otherwise, you could hit second on. Anyway, go to. I like go to because it tells me what's the problem. And it's saying, oh, I was in the middle of that when you stopped me. So what was doing is cranking through 8 million things on the table. Because my table settings were at the year 2042. I want this one to start at 0 because that's my starting number. All right. So I'm going to go back to the table, and now it's a little more reasonable. And I hope you saw that it was the year n is 11, which would mean after 11 years. Do you get the difference between 11 being the 11th year and after 11th year? After 11 years of compounding. Nope. After 11 years, you were at 42,000. So 11 is the right answer. Right answer is 11. Yes. Nope. Because 10 was close, but after the 10th year is what this is. After the 10th year had elapsed, at the very end of that year, I still only had 39,000, and that's not, sorry, 3,900, and that's not quite doubled. I get what you're saying, but you should not, no, you can't be that vague. At the end of your 10th year, you were not at 40 yet. It wasn't until you hit the 11th year that you climb up into the 4,000s, which is where it doubled. So we look at the table further. Okay, so this very first thing, remember, this is what we started at right here. We started at 2,000. So really right here, that's after 1 year. At the end of the first year is done after 1 full year. Now it's worth, so like think of it as on December 31st, it was worth 2,140. December 31st of the first year. So it seems like the second year, but it's not. It's the first year. So it's like these two are really almost in the same year. This is on January 31st, like when, or sorry, January 1st, the very beginning of the year when you started. And this is like the very end of that same year. See what I mean? So it's almost like the first two are from the same year. But the way to think of it is, the 1 means after 1 year, I have that much money. After 2 years, I have that much money. Blah, blah, blah. After 8 years, after 9 years, after 10 years, I still have, on the last day of that year, not quite gotten to the 4,000. So I need to say after 11 years. And yes, it's during the 11th year that it actually would change over. But it's definitely not the 10th year. Okay, so I think we've done enough practice. Let's get to your actual homework. Oh, actually, I'm wrong. We need one more thing I got to teach you. All right, this is a recursive, write a recursive formula for a loan that you're going to pay off. And how long would it take you to pay off if you had loan payments of a certain amount? All right, I'm going to give you something that's like a crucial formula. And for this problem, so I'd like you to make sure you write down this formula that I give you. Really good notes. You're going to need to see the problems like this. This is the most complicated way to do them, and we'll be doing it this way for the next week and a half. Okay? It's the same basic formula as we had. Remember how I said you always start with u sub 0 on real-world problems? For the rest of the time, it's pretty much always u sub 0, because they're pretty much always real-world problems from now on. And then it's the amount you start with, and that's fairly simple. 20,000 left in loans. Okay, so we have a loan of $20,000. Then it's always, I told you this would always be UN equals UN minus 1. That's still always there. But this next part gets a little more complicated than it used to be. You know how I used to say it was just 1 plus something or 1 minus something? On this kind, they're always going to be 1 plus something. No matter whether it's a loan or an investment, that'll always be a 1 plus. The next part is the rate involved in this loan or in this investment. And the rate will always go on the top. So in this case, the rate is 5.5%. You don't put 5.5 though. 0.055. Yep, you move that decimal over 2 spots. There we go. Now this next thing is, when we do these problems, we can compound them in any number of ways. Have you ever heard of quarterly payments? Have you heard of monthly payments? Okay, you've heard of that one because that is the most common. But there is such a thing as quarterly payments, which would mean 4 times a year. Or there's such a thing as monthly payments, which is 12 times a year. Or, of course, if you can just want to, you can pay it 1 time a year. And that's what we've been doing up till now. We were always assuming 1 time a year. That's why this divided by 1 never needed to be there before, is because we were always assuming it was 1 time a year. In the real world, do you get most things are monthly? So we need to divide by 12. That has to be a new part of your formula all the time from now on if we're doing monthly, which almost all the problems are. What is monthly? That means 12 times per year. This problem is monthly, yes. I believe it's monthly. Let's double check. Annual compounded interest, you pay for cause, and then right. If you paid, there it is. Here it says 100 a month. 100 a month. So yes, we're going to be doing monthly for this. Okay, so that's the thing that says monthly. That's the rate. That's how often you pay it. And then the last thing is, if you're actually going to pay off the loan, you need that 20,000 balance to go down. We want it to eventually go down to be zero balance. You don't owe anything anymore, right? So if you want it to go down, you have to make a loan payment to a subtraction there. You're subtracting off some money that you're going to pay. All right, it says you're going to pay 100 a month. There we go. That is the formula that you're going to need to know for all of the loan and investment problems that we do. This is your payment right here. That's the new thing we never had before. And this is how often we make that payment. And we never had that before either. All right. Now, you know how I mentioned that middle line in your calculator, if once you get that like deleted, you have to retype it all fully. It's good to practice that now and then, but I'll be honest, for me and you from now on, if I were you, I would want to leave that middle line completely alone and only change the interest rate or change the payment. You don't want to have to retype it because it's going to be a pain in the neck. So let's type this puppy in right now because you can see how it's going to have parentheses in certain spots to make it not be goofed up. Like I need parentheses right there to keep this from getting messed up. Let's type it in once together here. All right, so everybody grab your calculator. I'm going to have to do this off to the side. Those of you that are at home, I'll have to keep sliding it back and forth. So, all right, so U0 equals 20,000. So I'm going to put in a 0 at the top and a 20,000 right here. 20,000. The average college loan nowadays is about 28,000, so we aren't too far off at this estimate. Then U sub n minus 1, that's all good. Nothing to change there. Times 1 plus, nothing to change there. But this is where it starts getting a little more hairy because we've got to put in that 0.055 divided by 12 part. I would recommend another set of parentheses right here. 0.055 divide by 12, end parenthesis, end parenthesis. And now I can do, if it's a loan, it'll be minus whatever the payment is because you want the balance to go down. Minus $100 a month. Did you catch that? You can tell if you did it right a simple way. Let's just go do a U sub thing on the front screen. So I'll quit out of this and try doing U sub 2. And we'll see if we get the same thing as each other. And if we do, you know your formula is the same as mine exactly. U sub 2. What does that mean? That means how much is the loan balance after a couple of years? Do you get that the loan balance went down? It was 20,000, now it's 19,000. Why did it go down? Because you were making payments. What if you're depressed that it didn't go down very much? Make 2 years of payments and it's only gone down. Is that 2 years? No. By changing it to monthly, that means 2 months. U sub 2 would mean 2 months later. So 1 year later would be U sub 12, right? Let's everybody do U sub 12. U sub 12. Do you get that your loan balance went down to 19,897? All right, it's still painful though, and it is in the real world. If you take a $20,000 loan and you only pay $100 a month on it, it's going to take you a long time to pay off that loan. No, $100 a month. This is a monthly thing. After 1 year, after 12 months, after 1 year, we've only paid off a couple $100 of it. How come? Because of all the interest. I agree. It's closer to 100. So we've only paid off 100 bucks. How is that possible? Because the bank's charging us interest. That 5% interest thing is what's killing you. Your payment is only enough to barely cover the interest they're charging. So it's only getting paid off a tiny bit because they're charging you 5% interest. And 5% interest on $20,000 is a lot of money. All right. Let's change the payment a little bit. Go back to the y equals. Change it to, let's say that you're making enough money on your job that you feel like you can pay off your loan faster. We can't change the interest rate. The bank sets that. But we can change it to, instead of minus 100, maybe we go to minus 400. We'll obviously pay it off 4 times faster then. Maybe even faster than 4 times faster because the interest isn't going to be able to accumulate so fast because we're paying it off. So now I'm going to get out, second quit. And now, do you guys know this? If I just hit enter again, it'll do the same calculation. It'll do U12 over again if I just hit enter. So U sub 12 is, oh, now after a year, I've got my loan down to 16,000. I paid a lot more of my loan off. Make sense? All right. So let's get to your homework for today. It's right here, growth and decay applications. And I have not given you much time to work in class here, so I'm going to need to adjust this. Can't seem to scroll. So let me see how much I can realistically expect you to do. Let's just do 1, 2, 3, and 4 for tomorrow. Have 1, 2, 3, and 4 done. All right, now help me get started on number 1. You know what? We're going to have to change our calculator around so much. Let's not do that. Let's go to the, let's do one where we can use the monthly payments thing. So maybe, all right, the monthly payment thing we're just not going to use very much today. Sorry, there's not any on the worksheet. So you're going to need to know that. That's the hardest kind. But I guess the first few problems here, 1 through 4, they aren't going to use monthly. So let's do number 1. Suppose the recursive formula U0 equals 100 and blah, blah, blah. Miles a bouncing ball. The first part is just give real world numbers, real world meanings for the numbers 100 and 0.2. Just tell me, what is the 100 if we're talking about a bouncing ball? Yeah, it's the starting height. Okay, so let's just start height. And then the 0.2, what is that? In the context of this question, is it like how many chickens there are in your backyard? No. What is it? Because of the fact it's being subtracted, you should be able to use a certain word about it. It's the decay. Decay what? Percentage would be an okay word, but there's a word we've been using more often. Rate. Decay rate. Okay. Number 2. Suppose the recursive formula, blah, 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 describes an investment made in the year 2003. Give real world meanings for the numbers 250,000 and 0.25. Okay. Well, if that's an investment, what's that called then? What is, what? Yeah, it's how what you put in. I like that. There is an official word for that, but I like that. What you put in. You don't have to know this word, but it's called principal. In the investment world, it's called the principal. What you put into the investment. Okay, and then the 0.025, what's that? Growth what? Growth rate. All right. The table below shows investment balances over time. I got to scroll up somehow here. Write a recursive formula that generates the balances in the table. How am I supposed to know what rate this was? Divide it. You got it. And which way do I divide it? You always take this one divided by the second one divided by the first one. You know what I mean? You take the 2170 divided by the 2000, and that'll tell you your growth rate. Then you should be able to put that puppy into your calculator and answer the next couple questions. All right, for your hour, I'm going to stick to my 1 through 4, but I have a feeling in my other hours I'll be able to get through this a little faster. So you're assigned problems 1 through 4, which is probably a little too easy now, but you have virtually no time left. So, okay, that's all I got for the video for today.